Example number 11. For the function below, find A, the critical numbers, B, the open intervals where the function's increasing, and C, the open intervals where it is decreasing. Our function is a polynomial. F of x equals x cubed plus 6x squared plus 12x plus 8. So to find our critical numbers, we take the derivative. So f prime of x is 3x squared plus 12x plus 12. We're going to set this equal to 0. And this tells us that we have a quadratic equation. You can either factor it or you can use the quadratic formula. Since this factors easily, I will use factoring. If you want to use a quadratic formula, just go out to YouTube and look at a couple of examples. I factor out of 3, I get x squared plus 4x plus 4. This factors into two binomials, x plus 2 times x plus 2. I have 3 factors. I set them equal to 0. The first one results in no values because 3 is never 0. These two result in the same value. X is negative 2. So I have only one critical number. So I put my critical number on my number line. And I have no places where my derivative does not exist. And negative 2 is in the domain of the original function. So that's definitely a critical number. So I'm just going to test something like negative 10 to the left and 0 to the right. So f prime of negative 10 is 3 times negative 10 squared plus 12 times negative 10 plus 12. So that's 300 minus 120 plus 12. I think it's like 192. Doesn't really matter. It's positive. So in this region, our derivative is positive, and that's from negative infinity to negative 2. That means my function's increasing here. Now I'm going to check f prime of 10. So that's 3 times 10 squared plus 12 times 10 plus 12. And this is definitely going to be positive. So it is also increasing here. Now, because negative 2 is not excluded, that means that this function is increasing from negative infinity to positive infinity. Even though it has a critical number, the function doesn't change signs there, so this function continues to increase the entire time. So we can mark that it's never decreasing, that the function increases from negative infinity to positive infinity, and that the critical number is negative 2.